Well, first of all, let me welcome you all here on this glorious autumnal evening or morning or afternoon, wherever you are in the world. I say that with particular reference, bearing in mind our speaker who we have here today, who I shall come on to in a second. This is another of TNMOC's author talks, presentations. Tonight's subject is white elephant technology. We all know that technology and engineering and invention are driven by inventors and by the passion of individuals who kind of see something that other people can't, by a vision, if you will. But as we all know, that doesn't always quite work out, does it? We all kind of know the tech sector and engineering sector extremely well. We've seen great ideas come along, been pitched very heavily as the next big thing, or by insiders or even outsiders, and they never quite come off. Well, we're here today with John Geoghegan, and I hope I pronounced that correctly. John, please do correct me if I've got that wrong.
Close enough.
Thank you. He's a well-established author and writer based on the West Coast. He's in California, which is alluding to my reference earlier of wherever you are in the world. He's joined us horribly early his time, and he's spent a career covering this white elephant technology. And he's written about it for publication in newspapers, and he's done his latest book, which is available through the History Press, which he's about to take us through this evening. He's going to focus on five ideas in particular. Now, I want to set your expectations. This is not about sniggering at the fails, although, well, not completely. When you hear, if you haven't read some of these ideas already, you will certainly snigger. It's also about the lessons learned, and as we all know, success has, as the saying goes, success has many fathers, mothers, and failure has very few of them. But invariably, success comes out of trial and error, and very often the error. We've all seen that. And John's going to chat a little bit about that this evening, or this morning and this afternoon as well. Just a few little housekeeping reminders for you. One is we are recording. If you don't like it, I respect your decision, but we'll have to ask you to leave. Please show yourself to your door. We're going to take questions, obviously, naturally, always do. We'll be taking those at the end, if you don't mind. So keep those stored up for us. And please keep your mics on mute. Just so we don't get background interference, because Zoom doesn't like it, as we all know. So without further ado, over to John, who's going to take us through 45 minutes discussion. John, over to you.
Great, Gavin. Thank you so much for that introduction, and greetings to all of you Zoomlanders out there in cyberspace, all the ships at sea, all the astronauts in space. I'm John Geoghegan, coming to you live from the Silo Research Institute in San Francisco, California. And my talk today is going to be the 5 unusual inventions that failed, or why being brilliant isn't everything. It's based on my recent book, White Elephant Technology, 50 Crazy Inventions That Should Never Have Been Built and What We Can Learn from Them. It was actually published by a UK publisher, the History Press, last year. So let's start off with a very fundamental question, which is, what exactly is white elephant technology? All right, well, white elephant technology is basically any unusual invention, past or present, that fails in the marketplace despite its innovative nature. That qualifies as white elephant technology, or as I like to call it, wet tech for short. The 5 inventions I'm going to talk about today are probably ones most of you have never heard of. That's because they failed. Importantly, none of these 5 inventions are speculative. Each one was built, field tested, and worked more or less as planned, except in the unfortunate cases when it killed its inventor. Now, these inventions, I think, showcase their inventors' talent for inventing something nobody asked for. And given how misguided some of them are, I think you'll probably shake your head and wonder while asking, what in the world were they thinking? This presentation seeks to answer that question. So why is white elephant technology important? Well, first of all, what most people don't realize is the line between success and failure can be razor thin. Luck timing, and market conditions have as much to do with an invention's success as the technology. For example, 600,000 new inventions file for a patent each year in the United States, yet most never make it to market. Put another way, success for even the cleverest inventor sometimes comes down to a roll of the dice. Nevertheless, our culture prizes success more than failure, yet few of us realize just how often commercial endeavors fail. Let me give you some examples. Failure in general is the rule, not the exception. More than 80% of all books, movies, popular music, and video games fail to turn a profit. 85% of all new grocery products are pulled from supermarket shelves within a year of introduction. And 90% of all patented inventions never earn a dime. So in other words, failure is the rule, not the exception. And high failure rates aren't confined just to business. Let me give you a typical American example, which is baseball. A 300 batting average is considered excellent, even though what it really means is that a baseball batter fails to hit the ball every 7 out of 10 times they're up at bat. So put simply, failure is a significant part of life. There's even a museum of failure that's touring the world. In fact, they'll be opening in London in April 2024. Now, all this failure doesn't mean that we should stop striving. After all, where would we be if Columbus hadn't failed to find a better trade route to India, or we'd given up on reaching the moon after the Apollo 1 disaster? I think we agree the world would be a lesser place. Simply put, we're better off for trying even when we fail. So one reason why I think white tech inventions are worth studying is that failure has a lot to teach us. A tremendous amount of talent, perseverance, and sheer out-of-the-box thinking go into creating something, even when it fails. That's why the ingredients necessary for inventing something, including grit, ingenuity, and optimism, are the same ingredients for success. But what really drew my attention was the heroic investment inventors make in their inventions, even when they fail, which is why I consider white elephant technology one of the purest expressions of the human condition. Now, as Gavin mentioned earlier, I've specialized in reporting on white elephant technology for nearly 20 years. I've written about it for the New York Times Science section, Popular Science, and Smithsonian Air and Space magazine, to name just a few publications. I've even written 3 nonfiction books and worked on 4 television documentaries, each with wet tech inventions at their core. So focusing on failure may seem crazy, but I don't think so. As a television commercial for Apple computers once noted, it's the people who are crazy enough to think they can change the world that do. Where would we be without them? So let's take a look at our first invention today. And it might be one you folks are familiar with. We'll see. In 1921, a wealthy Scottish inventor named George Benny patented the Benny railplane. Here's a picture of the first working model. The Benny railplane was a monorail with a streamlined car that had a propeller on either end and hung from an overhead track. The invention was so unique, Benny, who you can see on the left side of this picture, was granted the first UK patent to use something that was called aerial tracks for guiding aircraft. It's interesting that it was listed as aircraft, even though it's a suspended train. Now, Benny's railplane was certainly revolutionary, but as you can see, it was more train than plane. Its canister-shaped coach with a propeller at either end was particularly memorable looking. Now, Benny first proposed building a mile-long connection between two neighborhoods in London. The necessary permissions were actually granted, but the project ground to a halt due to local opposition and a lack of funds. Despite these setbacks, Benny was determined to build a full-size prototype. And I think you'll see that this is one of the defining characteristics of wet tech inventors, that no matter what the setback is, they are determined to soldier on. So finally, in 1929, Benny got approval to build a test track just outside his hometown of Glasgow. Here it is. Benny's railplane was suspended from a monorail with a stabilizing track beneath it to prevent the carriage from swaying. It had two electric motors, which drove the railplane's two-bladed propellers at speeds promising to reach 120 miles per hour. Braking was achieved by putting the propellers into reverse, as well as by slowing the wheels that were attached to the carriage to its overhead monorail. Now, as you can see here, the Benny railplane ran along a huge lattice-like structure made of metal. It rested on concrete footings, and its monorail track absolutely towered over the landscape. Benny also intended his railplane to straddle existing railroad lines, and this was a key feature because zipping above railroad tracks, providing luxury high-speed rail service to passengers who could afford it, then allowed slower moving freight to travel by train on the conventional tracks below. So the idea also was that Benny would not have to apply for right-of-ways to build his railplane if he could partner with existing railroad lines, because he could simply build his suspended railway above the existing tracks. Now, the railplane's coming out ceremony took place in July 1930. There were 140 invited guests and VIPs, including Benny's mother and sister. That's Benny in the center of the photograph, wearing what looks to me to be a bowler, but maybe not quite. And his mother is on the left side of the picture, and I believe his sister's on the right. Climbing a flight of stairs to a platform that was high above the Scottish countryside, the guests were greeted by Benny, who was wearing a raincoat and a bowler hat. He nodded affably, spoke a few words to each person before they boarded his train. Now, also, the interesting thing is that test track was about 500 feet in the air, but it was less than 500 feet long, making for a very short ride. Still, it was an impressive demonstration. One writer said that the Benny railplane, quote, operated with perfect smoothness, and passengers only knew the car was moving by gazing out the window at the passing landscape. Now, Benny's demonstration coach, which could carry up to 24 people, was outfitted with plush carpeting and curtains, had comfortable seats, and small tables. It also had 6 large rectangular windows on either side of the coach, plus 2 smaller portholes providing excellent views. There was also a door at either end of the coach with an oval window with panes of beveled glass. Now, if there was a drawback to the railplane, and there were a couple, it was its cramped interior. There were many support columns which made the carriage feel narrow, especially when filled with passengers, as you see in this picture. That's Benny, by the way, standing at the end of the carriage. So after the festivities, Benny turned his railplane into a local attraction. Anyone with a shilling could afford to take a ride. But despite worldwide media attention, no investors stepped forward to commercialize Benny's invention, and the attraction closed after only 2 months. The railplane's economics, combined with the Great Depression, were responsible for sinking the project. The railplane required a lot of expensive infrastructure built from scratch. And though existing railroads could have provided the right-of-way, They saw Benny as a competitor, not a profit-making partner. Which is kind of interesting because railroads traditionally make money on freight and lose money on passenger service. So Benny was not crazy to think that if he could provide profitable, high-speed passenger service, that the railroads would jump into partnership with him, but they didn't. So without their cooperation, the expense of land acquisition made Benny's plan just too costly. And since Benny had financed much of the project himself, which often happens with wet tech inventors, he ran out of money. In 1936, he resigned from his company. Some reports actually suggest he was ousted and declared personal bankruptcy the following year. Sadly, the Benny railplane did not survive its inventor. Its Scottish test track was dismantled in 1941 and sold for scrap to aid the war effort, while the railplane coach was left to rust in a field. Although remnants of the track can be seen today, primarily the concrete footings, the actual railplane, except for a scale model, has been lost to time. Benny, who never married, ended up running an herbalist shop in Scotland after that. He died in obscurity in a nursing home in 1957. He was only 65 years of age. So it's a sad ending to that story. But if a propeller can make a train go faster, just imagine what a jet engine could do. This brings us to our next invention. That's basically what the New York Central Railroad wanted to find out during the summer of 1966, is what would happen if you mounted twin jet engines on a railroad car. The M497, as you see here, which was also nicknamed the Black Beetle, was the world's first jet-powered engine. Alfred Perlman, who was president of the New York Central, personally approved the project. He had saved the railroad from bankruptcy and was desperate to lure passengers back and hoped that the publicity around a high-speed train might do the trick. But revitalizing train service in the United States was a tall order by 1966 because the public had basically abandoned passenger railroads in favor of their personal car, which was more convenient, or air transportation, which was quicker. Using a Budd Company rail car it had purchased in 1953, the New York Central sent it to its Ohio Technical Center to be fitted with two surplus General Electric J47 jet engines. These jet engines were actually used on Air Force bombers, and they were bought secondhand for the bargain price of $2,500. The jet engines were converted to run on diesel fuel and mounted on the front of the train at a downward-facing angle. A slant-nosed fairing, which you can see here, which looks a bit like a welder's mask, was added to the front of the locomotive to reduce wind resistance. Additionally, more than 50 instruments were added to measure speed, stress, and ride quality. A black paint scheme that was designed by the wife of the project's engineer gave the train its nickname, the Black Beetle. So testing took place over a July weekend along a 21-mile section of track. The track ran between Indiana and Ohio, and it had to be upgraded to accommodate the Black Beetle's anticipated speed. In fact, the railroad crossing guards were lowered in advance of the test and locked into place because the train would be moving so quickly, it would have already passed by the time the guards came down. The railroad ties were also placed across the end of the test track to derail the M497 if it ran out of control. The test was considered so important that the New York Central's president, Mr. Perlman, actually attended both days of the testing. Driving the train was the man who helped design and build it. Don Wetzel was his name. Wetzel was the New York Central's assistant director of technical research. He was a former Air Force pilot. He was also licensed to engineer a train. Now, the Beetle ran 2 high-speed tests on Saturday, July 23rd and Sunday, July 24th, 1966. You can see the heat waves coming off the jet engines as the train rockets down the tracks, kicking up a cloud of dust in its wakes. The Beetle's jet engines ran so hot that their automatic shutoff feature had to be disabled to prevent them from shutting down. And the thing was so loud that the trackside neighbors thought a jet fighter was making a low-level pass. Now, Wetzel, who drove the train, he claims he was so petrified he never once let go of the whistle cord during the entire 21-mile run. Now, it was hoped that the Beetle would reach a top speed of 180 miles per hour, which for 1966 was not bad. But instead, it hit almost 200 miles per hour, a world record for a light rail vehicle traveling under its own power. Now, the Beetle proved that high-speed rail service could travel on conventional train tracks, but her configuration was impractical, which makes her a wet tech invention. The Beetle's jet engines made the train so tall it couldn't fit under any railroad bridges or through the tunnels on the rail line. Additionally, the jet engines had no reverse, so the Beetle had to be towed back to its starting point by the very type of diesel locomotive she was intended to replace. Now, the New York Central never put the Black Beetle into production. Instead, its jet engines were removed and used to melt snow. Now, let me see if I actually have yes, I have brief film footage showing one of the tests of the Black Beetle in action. So let's take a look at that. It's silent, by the way. So they're panning across. You can see there's the Black Beetle with the jet engines, twin jet engines on its roof. There's a close-up of the engines. There's Don Wetzel climbing up into the locomotive itself. Pride of the Central. I mean, they had great hopes for this invention. Don's inside. Okay, now this is a traditional diesel locomotive towing the Black Beetle to the start of its test, because as I mentioned, the jet engines had no reverse, so it couldn't go backwards. It had to be towed, which I think is kind of funny. And here we go. Here's a long distance shot of the Black Beetle under its jet engine power. The foreshortening makes it seem like it's going slow, but wait until it passes. You can see just how much dust and dirt this thing kicked up, which would have been a problem, of course. Okay, I think that's it. Great. So as I mentioned, they never put the Black Beetle into production. Instead, they removed the jet engines and used them to melt snow on the rail line. The M497 rail car itself was returned to service, but 2 years later, the New York Central merged with the Pennsylvania Railroad because of the bad finances, resulting in the combined company being called Conrail. And Conrail was eventually sold to New York's Metropolitan Transportation Authority, which was the subway system. And the MTA ended up cannibalizing the 497 for parts before selling the rest of it for scrap in 1984. So again, a somewhat sad ending for a wet tech invention. That was the end of the world's first jet-powered train. Now, our next invention, I think, is equally weird. Its inventor, Dr. John Archibald Purves, was another highly credentialed Scottish engineer whose day job was supplying electricity to English communities. But electrifying the countryside didn't make Dr. Purves famous. Inventing the dinosphere, shown here, is what did it. Now, the dinosphere is known generically as a monocycle. And according to Dr. Purves, it was the, quote, high-speed vehicle of the future. By eliminating 3 out of a vehicle's 4 wheels, Dr. Purvis claimed he'd reduced locomotion to the simplest possible form. Dr. Purvis built several prototypes of the dinosphere, including at least 2 full-sized gasoline-powered versions. Now, as you can see from the picture, the dinosphere was an open-air vehicle, meaning passengers got rained on or had wind and dirt blown in their face. But there's this terrific photograph taken in 1932 of the inventor's son driving a dinosphere. Here it is. Love this picture. Bald with 2 tufts of hair standing right up on either side of his head. He looks a bit like Larry Fine from the Three Stooges. Because of the efficiency of the design, the dinosphere did not need a powerful engine to generate a lot of speed. But this could be a problem when it came to braking, because the only way to stop the 1,000-pound monocycle was to turn off its engine. Another obvious discomfort was the driver's seat rocked back and forth when accelerating or braking the dinosphere in a phenomena called gerbling, because it was like a gerbil in a hamster wheel. It made riders somewhat uncomfortable. Now, in a 1932 Pathé newsreel, a woman who's possibly Dr. Purvis's either wife or mother sits in the dinosphere while explaining how it works. You'll see in this newsreel, which I'm going to show you in a second, that the invention clearly wobbles when it starts, but it gains stability as it increases speed. And the gerbling problem is also quite apparent. So let's take a look. There's the gerbling I was talking about. You can see it gerbling a bit here too. Okay, so Dr. Purvis was granted a U.S. patent for this invention in 1935. That same year, a cover story in Mechano magazine waxed enthusiastic about the dinosphere, saying it possesses so many advantages that we may eventually see gigantic wheels running along our highways in as large a number as motor cars today. Fat chance. It was hard to steer, and it was also difficult to brake. As a result, the dinosphere remains the poster child for white elephant technology. All right, let's move on to our next invention. If you're ready for this, it's kind of a change of pace. Tanks were known for 2 things in World War II: their mobile firepower and their heavy armor, which shielded them against attack. What they weren't known for was swimming. But the Allies needed to get tanks ashore during the D-Day invasion. The goal was to create an amphibious tank which could swim to the beachhead all by itself, rather than be delivered in a specialized landing craft. Given that the M4A1 Sherman tank shown here weighed 33 tons, and had armor 3 inches thick, you'd think making one float was a bad idea. Nicholas Strassler, a Hungarian engineer working for the British, was charged with finding the solution. Now, Strassler was a specialist in designing amphibious military vehicles, but the problem he faced overcoming the tank's considerable weight was not trivial. Strassler's answer was to develop a waterproof flotation device, a kind of canvas skirt, which you can see here, that surrounded the outside of the tank, displacing enough water that it enabled the tank to float, or so went the theory. The collapsible skirt, which left the tank's top open to the elements, was raised into place using compressed air. Once inflated, metal scaffolding was snapped into place to provide support to the skirt. Now, the D-Day invasion plan included offloading the swimming tanks 2 miles from shore. But since they sat so low in the water, the tank part was not visible to the enemy. In fact, the surrounding skirt makes it look like a boat. There was a periscope extending from the tank's turret, which enabled the driver to see where he was going while he used a compass for navigation. And these twin 3-bladed propellers underneath the tank's rear carriage delivered a maximum speed of 4 knots. They could also be swiveled left or right for steering, and there was an automatic bilge pump inside the tank to keep it dry. As the tank approached the shore, it would collapse the front of its skirt like an accordion, allowing its 3-inch gun to fire. Once on land, the rest of the skirt was quickly deflated, enabling it to proceed as a conventional tank. Now, I also have a brief video I want to show you of what the swimming tank looked like in action during its tests. Oh, that's just a diagram here. Before we get to the video, let me just add. So basically, it was called the DD M4A1 Sherman tank, with DD standing for duplex drive, its 2 means of propulsion. It was a hybrid, though, and it seemed destined for failure. So no one was surprised when military wags, instead of calling it the DD tank, called it the Donald Duck tank. So let's take a look at that video I mentioned. There are the propellers swiveling. You can see them turning. I wouldn't want to be standing behind it if it backed up. Here they're putting the compressed air tanks into place to inflate the skirt to raise it before going into the water. Here they're trying to raise the skirt with the compressed air and putting the metal rods into place to give it extra support. And they're off into the water. They did these tests in a river, not in the open ocean. So that's why it looks relatively calm. Love the music. And there they are coming up on the other side of the riverbank. So as you can see from the test, it worked more or less as planned. They're collapsing the skirt. Okay. So you get the basic idea. But Strassler's invention had several non-trivial problems. First, the tanks were so cumbersome They were difficult to steer in the ocean. Additionally, they sat so low in the water that they were prone to swamping. And unfortunately, the waves off Omaha Beach, the morning of June 6th, 1944, where these tanks were deployed, were 6 feet high, not the 2 feet high that the tanks were designed to withstand. So the moment of truth came when the 5-man tank crews had to seal themselves inside their steel-plated coffin before being deployed 3 miles, not 2 miles, offshore in the middle of a storm. You know, I feel like they must have known in the pit of their stomach that things weren't going to go as planned, but they got in anyway, which to me is just an amazing act of courage. So of the 29 swimming tanks launched off Omaha Beach, 27 sank like a stone with their tank crews trapped inside. Canadian and British tanks did somewhat better due to calmer seas. But of the 120 tanks launched that day, at least 42, or more than a third, disappeared beneath the waves, where many still remain today. Now, Strassler, who had 30 patents to his name, continued working on a variety of projects up until his death at 75 in 1964. And although he did make other contributions to the war effort, he'll probably always be remembered, not altogether fondly, as the father of the swimming tank. All right, on to our next invention. So if a tank shouldn't swim, my next question to you is, should submarines fly? Well, that's exactly what Mr. Reed wanted to do. Now, I'm sure you'd agree with me that a flying submarine doesn't make a lot of sense, but that's exactly what Donald V. Reed built and tested in 1964. Now, Reed, shown here inside his invention wearing the helmet, was a classic wet tech inventor. He built his Reed flying submarine, or RFS-1, as he called it, in his backyard. He was an inveterate tinkerer and had a history of using whatever he found to make his inventions work. In fact, Reed once borrowed the motor from his wife's Kenmore vacuum cleaner to build a model helicopter. He also used the family toaster for a powerboat he raced and won first prize with. Even Reed's son, who penned a sympathetic biography of his father, called him eccentric. But Reed showed mechanical aptitude from an early age, like a lot of wet tech inventors. He would take apart clocks as a kid to see how they worked and then put them back together. He had a day job at the Naval Turbine Test Station in New Jersey, which meant that he was more skilled than the average hobbyist. But the idea of a flying submarine has been around for a long time, but mostly in the form of science fiction. But the story of how Reed came up with the idea, even though it may be apocryphal, since many origin stories are, but he claims to have been working on a radio-controlled model submarine in his basement one night in 1956, when inspiration struck in the form of a pair of model airplane wings falling off a shelf and landing on his model sub. Hence, the flying sub was born. But combining an airplane and a submarine is a major challenge for several reasons. First, a submarine's hull has to be rigid and strong enough to withstand crushing pressure. This is in direct contrast to an airplane's fuselage, which needs to be light and flexible. But with the help of his family, Reed built a series of progressively larger flying submodels to prove his concept. His first prototype was completed in 1961. 2 years later, he was granted this U.S. patent for a single-seat float plane that could land on water, flood its floats, and sink beneath the surface, something seaplanes usually only do when they crash. So Reed's flying sub was assembled from junked airplanes and incorporated such objects as a steel bed frame and 2 galvanized trash can lids. As you can see here, it had a long cigar-shaped fuselage with wings and a tail. It sat on pontoons, which could be filled with water when it was time to submerge. And a 4-cylinder aircraft engine powered the craft in flight, while an electric motor propelled it underwater at a turtle-like 2 knots. Now, converting the RSF-1 from a plane to a submarine was complicated. The pilot had to remove the propeller before he could submerge. He also had to seal the engine with a rubberized gas tank. And since the RFS-1 had an open cockpit, the pilot had to don a wetsuit and a scuba tank whenever the plane submerged, which at its deepest would only be 12 feet. The most submarine-looking part of the RFS-1 was a pylon, resembling a subsail on which the propeller and engine were mounted, as you can see in this photograph. The pilot sat in the nose of the craft, but his head seems to me to be so close to the propeller, it looks like it might get chopped off. Skeptics called Reed's flying submarine the Flub, but a full-scale version made its first test flight on New Jersey's Shrewsbury River in 1964 with dual registration numbers, one for an airplane and one for a boat. What's clear from that test is that Reed's flying submarine was seriously underpowered. It barely got airborne, flying at an altitude of no higher than 75 feet. It skipped across the waves and could only manage short hops in the air. Submerged, it reached a depth of only 6 feet. But despite a shaky start, including an early crash, Reed's flying submarine did everything it was supposed to do. It flew, it submerged, and it resurfaced in a controlled way. Unfortunately, it did none of these things particularly well. The U.S. Military Invention Board reviewed the RSF-1 and deemed it impractical. Unable to find investors, Reed's flying sub was never commercialized. But for those who are curious, it can be viewed today at the Mid-Atlantic Air Museum in Reading, Pennsylvania. Now, Reed never stopped working on his inventions like a lot of wet tech inventors, and he died in 1991 at the age of 79. Now, that's 5 inventions, but I have one more bonus for you. It's very short, but I think you'll like it. Now, Detroit made a lot of styling mistakes during the 1970s, but none quite as egregious as the Ford Pinto. But that didn't stop it from becoming the key component in a flying car. Developed by California's advanced vehicle engineers and named for a star in the handle of the Big Dipper, the AVE Mizar married a Ford Pinto with the Cessna Skymaster plane. If looks could kill, this flying car was born to murder. Its inventor, Henry Smolinski, was a structural engineer with a background in aircraft design. His idea was to take a conventional automobile and integrate it with a small airplane so that a person could drive it to an airport, fit the car with wings and an engine, and take off from the runway. Smolinski told reporters, "Our plan is to make operations so simple that a woman can easily put the two systems together or separate them without help." Now, Smolinski's Pinto was modified so the driver controlled the wing steering by turning the steering wheel right or left, and pushing the wheel forward or pulling it back controlled the elevators on the tail, while floor pedals near the gas and brake controlled the rudder. Let's take a quick look at the Mizar in action. This is a promotional video that's done in German, but it's an excellent example of actually seeing this thing fly. It's a close-up showing the pusher engine, which clips on the back of the Ford Pinto. You can see the wings and the strut holding the wings in place. There's the interior. Not sure I would have chosen white. There's the instrumentation. She looks somewhat skeptical to me. There he is doing a systems check. She's walking around, making sure everything works. So you get the general idea. You know, the Pinto's gas tank would soon have a reputation for exploding when rear-ended, but that was the least of Smolinski's problems. An ill omen came during an early test flight when a wing strut failed, forcing the pilot into an emergency landing. But after he came down, the pilot simply drove the Mizar back to the airport. But the Mizar's most memorable act of violence was to disintegrate in midair in 1973 during a test flight. Shortly after takeoff, the Mizar's right wing folded, sending the car plummeting to Earth. As pieces rained from the sky, the Mizar hit a tree trunk before landing on a parked pickup and bursting into flames. Smolinski and his business partner, Hal Blake, were instantly killed. The AV Mizar was to be priced at $15,000, but sadly, it cost Smolinski and Blake a whole lot more. So that's a brief look at 5, or I should say 6 wet tech inventions. I think we need to remember the words of Mark Twain. Let us be thankful for the fools, but for them, the rest of us could not succeed. If you're interested in learning more about 50 crazy inventions, it's available for sale at the National Museum of Computing online or at your favorite local bookstore. And more importantly, if you have an idea for any wet tech inventions or want to submit a crazy invention of your own, please visit our website at www.whiteelephanttechnology.com, because we're constantly posting crazy inventions every week. Okay, now it's time to come back for the question portion of our talk. So I'm happy to take any questions you might have.
Thanks, John. That was incredible. It really is. There was a lot of interesting stories, and my personal favorite, I think, the George Benny rail plane was incredible. It's almost like they have these grand visions, and why didn't you just make a faster train? You know, putting propellers on trains, putting rockets on trains. What I mean, what were they thinking? I mean, why did they? What was the goal in trying to put a rocket on a train? Did they just think faster? Was that really all they had in mind?
Well, yes, and it would have been faster. You know, there was a problem. There was one big problem with it I mentioned, but another one was he had propellers mounted at both ends, so you couldn't build out a long train. You know, you couldn't attach other coaches like you could in a conventional passenger train. You only had one coach. The other thing is, would you like to stand on a railroad platform, Gavin, when one of those things pulls in with its spinning propeller?
No.
You know, and he never gave up the ghost, even though he ended up, you know, being a poor herbalist in Glasgow. He actually contracted with the government of Iraq in Baghdad to build a similar system connecting 2 Middle Eastern cities. It never got off the ground, but he never really gave up, which is what I love about these guys.
But some of these ideas are universal, because you mentioned that you got Elon Musk today with Hyperloop. You know, the flying car has never gone away. It's something that has persisted and persisted as an idea. People keep coming back to these ideas, don't they? Yeah,
I mean, they're evergreen. I mean, the whole history of flying cars is fascinating. You could do a class just on that. And of course, as you say, they've come back in a big way. The technology and the materials is really advanced. There's a couple of, there are several prototypes that are flying now. 1 or 2 have been approved by the FAA in the United States. The problem with these things, these flying cars, is usually the price. You know, it makes it a millionaire's toy because it's not something that a mass market can afford, even though I wouldn't mind flying around in one.
And something also is the technology, just the practicalities. You mentioned the price, but the Pinto, for example, the guy looked extremely dubious as he got out. I mean, where would you put the bits for your wings? Well, you've got to go out one day deciding you're going to drive or fly. You're not going to be able to drive, then whip out your wings and then take off, are you?
Right. The AVE Mizar meant, was detachable. So you'd have to store the wings and the engine in a hangar at the airport, which, increases the expense. But the technology today, it's all built in, so the wings fold in, the engine's always on the back. So they've kind of gotten smarter about solving that problem.
Does anybody have any questions here for John? They'd like to pop up. You can put them into chat, or if you want to just unmute, just ask John a question.
Yeah, don't be shy. I'd be interested to know if anybody had actually heard of any of these inventions prior to this presentation.
Not actually heard of them per se, but I remember when I was at school reading a book about somebody who'd built a flying submarine, which was also a service vessel. And it was the guy was somebody who wanted world peace, and he decided that his invention could cause that. And he tried to prove that it worked. I can't even remember the end of the story, and I've never managed to find the title of the book, so I can't tell you that. But it seemed to be a popular subject, I think. When I was searching for the book, I did find at least one other where of flying submarine. So it was something of a sort of boy's own type thing, nothing else.
So the flying submarine, yeah, it's fascinating again. And the corollary almost is, which is in your book as well, John, is the submarine aircraft carrier, which the Japanese Navy seemed to have a thing for, didn't they?
Yes, the underwater aircraft carrier that was built by the Japanese during World War II to launch a follow-up aerial attack, this time against New York City and Washington, D.C. I wrote a terrific book about that called Operation Storm for anybody who's interested in understanding what is an underwater aircraft carrier and what were the original plans. There's something about submarines, I think that they're just not meant to fly. But you'd be surprised how many people have actually tried to design flying submarines. And the U.S. military, which has deep pockets and can always be relied on to spend money on stupid inventions, basically undertook a study, a pretty extensive study on flying submarines. And they too finally had to give it up because they knew it's just not possible.
And it's if you've got any questions, just pop them in chat. I've got a few more, but I don't want to take up the time if you've got something really cool or interesting. Something I was also interested in the other idea, which is pervasive in your book, is atomic power, which was just like, what can we atomicize? Can we do a tank? Can we do a car? Can we do a submarine? Can we do an ocean liner? It's like, well, you can, but it's not terribly practical, is it? Again, do you think we're through? Have you seen that there was a height, maybe a peak of that sort of like zeal to put atomic everything out there? Was it after immediately in that kind of like Cold War era, or is that still with us, do you think?
Yeah, it's interesting to me. I've learned over time there's a pattern. Whenever a new technology comes out, like in the case of the airplane, and they have, combustion-driven propellers. Okay, they work great for airplanes. And then what happens is everybody starts applying that technology to things they're not so great for. So we saw a whole bunch of trains that were propeller-driven. And not only the Benny rail plane, but the Germans had the Schlein Zeppelin train, and the Russians had a propeller-driven train. None of these things really worked. Same thing for atomic energy. Once we split the atom and they came up with the atom bomb, then they were looking for peaceful applications for atomic energy, and they started to put them into all crazy things. I mean, first of all, putting atomic energy in a car, okay, great, you never have to refuel. But do you understand that the amount of lead shielding that you would have to have in a car to protect you against the atomic plant is ridiculous. And of course, when they were doing this was in the 50s, when the technology was really immature. So now they have atomic plants that are lighter and more portable. But in the 50s, they wanted to put they wanted to have atomic powered trains, which they designed. They wanted to have atomic powered cars, which basically never got to the prototype stage. They were usually just scale models. They were looking at atomic airplanes. Oh, terrific. The United States Air Force had a program to build an atomic airplane. I mean, imagine what would happen when that thing crashed. And then, of course, the ultimate craziness was they were looking at atomic powered airships. Now, we all know what the record is for airship disasters. So imagine an airship powered by a nuclear plant crashing somewhere. Fortunately, none of these things really got off the drawing board. They even had an atomic, Chrysler was looking at a prototype of an atomic powered tank. Again, so what would happen, in war if somebody hit that tank? It's I guess the initial enthusiasm of a new technology soon gets, extended to the point of ridiculousness.
You mentioned two things struck me was I was intrigued in your book by steam power also had a brief kind of, I suppose, renaissance, the steam powered car and the steam powered plane. I mean, again, we've seen people today trying to find their way out of the diesel engine or the petrol engine. We see electric planes now coming on, and we see obviously electric cars. And these people are, again, ahead of their time. Just the technology wasn't there. I mean, I was intrigued by the steam, the Besseler brothers. They just didn't care. They didn't feel the need to pursue the idea any further, did they? They just seemed like they wanted to make it and move on. Whereas Abner Doble's, like, if I'm pronouncing his name right, his car, he kind of wanted it, but he was too much of a tinkerer. It's two kind of extremes, isn't it? So were these guys so far ahead, or did they have that vision, or they just like steam so much, do you think?
Gavin, I think you're exactly right. One of the things that fascinates me about wet tech inventors is, I mean, these guys were visionaries and they were way ahead of their time, and their vision exceeded what the technology and the materials of the day could provide in a lot of cases. And that's part of the human condition for me. The tragedy of these stories is, years later, you see their ideas being, we circle back to their ideas and they get reapplied. And because the technology is advanced further and the materials are fundamentally more robust, then their ideas start to succeed. But these poor guys are kind of lost to history and dismissed as crackpots when simply they had a vision that was ahead of its time.
Mm. It was.
The thing about steam power, I think, is another perfect example of the pattern. We had steam driving trains and in the Industrial Revolution at factories in a very widespread and successful manner. So then we're going to start applying steam to all sorts of crazy things, like an airplane. Who wants to fly in a steam-powered airplane? I mean, there were reasons for it, but the Besseler brothers, who you mentioned, were really sharp businessmen. And that's what most wet tech inventors are not. They're entrepreneurs who can come up with a great idea, but they can't scale it. They can't get it into mass production. The Besselers never wanted to really build a steam-powered airplane. They just wanted to demonstrate how light and small and robust their technology was, so they could sell it to the train industry, which was where the killer app really was. So it's interesting that some inventors have the skills to scale up their idea, whereas most do not.
And Abner became an evangelist for steam power. Did he just believe in all things steam, or did he have like am I kind of projecting too far back, and that he had like a green kind of concept, or what was his motivation?
Yeah, certainly there was no green concept to it. I mean, Abner Doble, who came up with the Dobner Model E in 1924, it was a steam-powered car. For those of you who haven't read the book, it was a steam-powered car that today exceeds the specs of most cars on the road today. It has a far greater range. It has zero pollution capabilities. It has a speed of 0 to 60. It's superior to any internal combustion engine car on the road today. And he built this steam-powered car in 1924. Doble was a steam evangelist, and right up, even though he played around with the stock and got hit by the Depression and was found guilty of stock manipulation, and driven out of the business. What did he do? Did he quit? No. He just simply went to New Zealand, Australia, and eventually England, and worked as a consultant for the steam-powered transportation companies there. And in the last years of his life, which were spent back here in California, he was working on the Paxton Phoenix in 1957, which was another steam-powered car. So these guys, you know, they're true evangelists, like you say. They believe in it so deeply that they're never going to surrender their commitment to their idea, which on some level could be crazy, but on another level, I really have great respect for their conviction and determination.
Indeed, and I suppose another concept I think is we think these guys are sort of lost in history. I think innovation has moved on to more, you know, silicon ideas and the algorithm these days. It's interesting, these guys are working with hardware and atoms instead. But one of them very recently, Mad Mike Hughes. I mean, I don't know if people remember him in 2020. I mean, he was big news, wasn't he? The flat earth rocketeer who died with his invention. I mean, that's recent history. These guys are still doing this stuff, aren't they?
Yeah, I mean, you know, they're definitely on a spectrum. You know, Mad Mike Hughes, who built a steam-powered rocket in his garage. You know, he really wasn't doing anything with the technology that was groundbreaking. And I tend to think of him more as a daredevil, you know, than an entrepreneur or an inventor, except that, you know, he had this crazy idea for building the Raccoon or whatever it was. You know, his steam-powered rockets maybe got him, they didn't get quite a mile high, which isn't that high. But this Raccoon, that he was doing all of these launches to build up enough money for his grand, you know, scheme, which, you know, I think was absolutely ridiculous. But I think he was a believer. And I interviewed his partner who helped him build that steam-powered rocket after Mike's death. And, you know, it was clear to me that Mike believed in what he did. You know, even though he was a daredevil and a bit of a carnival barker and sideshow guy, he was committed to doing this, even if it cost him his life, which it ultimately did.
Do you think, on a final note, do you think there's anybody we should have our eye on today? Anybody who's caught your eye? The latter day Mad Mike Hughes, the latter day Abners who are out there today? Take Musk out of the equation. I think everyone's got different views about him, but anyone else we should be looking to these days?
Well, okay, so that's a great question. I mean, I think yes, and the short answer is yes. I think the categories that I would be looking closely at right now are the jetpacks, which are coming back in a much more robust form. They still have the problem of limited range, limited flight time, but they're very close to solving the problem. And of course, flying cars, you know, the two great staples of wet tech inventions, flying cars and jetpacks, are coming back big time. The other thing that I would want to point out to, personal favorite wet tech invention of mine, is Sergey Brin is one of the co-founders of Google, and Sergey has personally funded a private startup company called LTA Research. You should Google LTA Research. They are building the next generation of big rigid Zeppelin. And in fact, I went down to Moffett Field, which is south of San Francisco, where the U.S. Navy had its Zeppelin program during the 30s. And Sergey and LTA Research and the CEO there is a fascinating guy, Alan Weston. They've actually built a 400-foot prototype of the next generation of big rigid aircraft. And you know, Sergey's a little bit like Jeff Bezos or Elon Musk in that he can write a check, can easily write a check to fund this vision that he has. And he is writing the checks. I mean, they've spent about a reported $200 million so far on the project. I've seen the Pathfinder 1 down at Moffett Field in Hangar 2. It's the real deal. And they're now scaling up an 800-foot version, which is larger than the Hindenburg was, at the old Goodyear Zeppelin air dock in Akron, Ohio. So I would definitely keep my eye on LTA Research. I think we're going to see a Zeppelin larger than the Hindenburg flying through the skies again. And by the way, it's filled with helium, not hydrogen.
I was going to say, I hope it doesn't go the same way as the Hindenburg.
Yeah. I was going to add, if I might, the thing with a lot of these guys, you're absolutely right in everything you say about them. You know, they're just driven with this idea. but quite often it's the commercial side of what they're coming up with that they don't always get, and which is sometimes the thing that brings it down. If I could just take flying cars as an example, I mean, yes, you're dead right, they've always been around, but to me, the thing that's always going to be the limiter is the number of pilots who can buy one. The man it doesn't matter what price they come down to, the man in the street's not going to buy one if he hasn't got a pilot's license, which is most of us.
Right. Phil, I think you're absolutely right. You know, it comes down to two things, and most wet tech inventions come down to two things. Well, you know, one is the business case. Does it have an economic model that's sustainable? And, you know, is there a market for it? Now, they're selling some of these flying cars, but, you know, they're selling them to, you know, rich Arab sheiks, you know, that type of thing. They're not going to be priced, and they're not going to be at a price that you and I can afford. I don't know. I can't afford it. Maybe you can.
No. But again, this is the point, though. Even if I could, there's no point in you buying one.
Inventors, all they want to do is they want to make make their invention work. They're not necessarily thinking of the business case or the market. They'll get to that once they get the invention, you know, get all the bugs out and get it working. But, you know, the problem is that as much as blood, sweat, and tears they put into their invention, often the situation is there's not a business case for it and there isn't a market.
Yeah.
Interesting. I'm just going to go on and say thanks, Phil. That's a great observation, a great question as well. Thank you. Well, I'm going to. I think I'll call it there. It's. We've had a good chat, and I think people want to get on. But I know that John, you've got a whole day ahead of you now, haven't you?
Sorry, I didn't catch that, Gavin. Can you say that again?
Yeah, you've got a whole. We're going to let. I think it's time to release you to your day now because you've got a whole 12 hours or so ahead of you now. You've got a working day in California to be getting on with.
Oh yeah, I'm actually teaching a class. I teach out here at the University of California at Berkeley and at the University of San Francisco. So I have a class this afternoon, hence the bow tie.
What are you teaching?
But listen. Thank you so much, Gavin, to you and to the National Museum of Computing for having me and putting me together with some like-minded enthusiasts when it comes to wet tech inventions. It can be a lonely road proselytizing about these crazy guys, but I really enjoy it, and I love the opportunity to share it with you folks today.
Well, thank you. It's a pleasure. If I can speak for everyone, I think it was a great, lovely, fantastic presentation, great stories, well illustrated. Thank you, and fantastic presentational style. And if you're over here in the UK, please come and drop in and see us as well. We'd love to have you over.
I will. I think there's a chance that I'm going to be at the opening of the Museum of Failure in London in April 2024, and doing some media there. So if that's the case, I'll definitely come by to see you guys.
Definitely, we'd love to see you.
All right.
Thanks. That's a date. We'll see you next year. Thanks very much, John. Thanks for your time. Good luck with the book. And don't forget, you can buy it through the museum shop as well.
See you guys.
Take care, everyone.
See you guys.
Bye-bye.
Bye.